This is the video lesson for lesson 11.1, triangles. Most of this should be a review, and I'm just going to go over some definitions and then do a couple of problems off of the homework, and then you should be able to do the rest. So just to review some things, when we talk about the word congruent, that means two figures that have exactly the same shape and the same size. This is the symbol that means congruent. It's an equal sign with a little squiggle over the top. One thing about congruence is the orientation does not matter. So it doesn't matter how a figure is turned, they can still be congruent. Okay, next, congruent polygons. We're going to be talking specifically about triangles in this unit, but any congruent polygons could be triangles, quadrilaterals, pentagons, it doesn't matter. But two polygons are congruent if and only if their corresponding parts are congruent. That means corresponding sides and corresponding angles. So if you have a triangle and this other triangle is supposed to be congruent to it, then the corresponding parts, like their angles, would have to be the same measure. So if this was 60 degrees, that would have to be 60 degrees. Their corresponding parts would be like also sides. So if that side was 5, then this side would have to be 5. That's going to be the same no matter how it's turned. A congruent statement states which angles and sides are congruent. So a congruent statement for a triangle, for instance, would be something like triangle ABC is congruent to triangle DEF. And what that statement tells us, it tells us that angle A is corresponding with angle D, so they would have the same measures. Angle B would be corresponding with angle E, they would have the same measures, and so on. It also tells us that side AB and side DE match, they're corresponding, and they would have the same length. Same thing with side BC and EF, they would be the same length, the same size, and so they're going to be corresponding. And so the congruent statement is very important. The order that you say this matters. So if you say triangle ABC and A matches with D, then you'd have to say DEF, so everything has to match. If I was to change my statement and I was to say CBA, for example, and if I don't change my second statement, then that all of a sudden means that C would have to match D. And if that's not what happens, then I also have to change my second statement around to match that as well. So I would have to say FED in order to have everything match up the way it should. So A is going to go with D still, B is going to go with E still. It doesn't matter if I said ABC is congruent to DEF or if I said CBA is congruent to FED. They both mean the same thing. However, to just make things easier, it's easier if the first statement, if you put that in alphabetical order, and then the second statement may not be in alphabetical order, but it will just go along however it goes. But then that way, we all have the same answer. So if I put ABC and you put CBA, then our second statements won't match up either. So it's just kind of easier to grade things that way if you have everything in the same order. So just take the first statement, put it in alphabetical order. The second part of the statement will just go as follows. Okay, the corresponding angles are the angles that are in the same position and they have the same measure. Now it says may have the same measure. They only have the same measure if you have congruence. So if two polygons are congruent, then they're going to have the same measure. If they're not congruent, then they can still be in the same position or the same area, but they may not have the same measure. Corresponding parts, that's any angles, sides, vertices that are in the same position, and corresponding sides are sides that are in the same position, and again, they may have the same measure, and that's if there is congruence. Some prior knowledge that you need to know: the sum of the angles of a triangle is 180 degrees. So that's any triangle, doesn't matter if it's a right triangle, an obtuse triangle, acute triangle, it doesn't matter. The sum of the angles is 180 degrees. The sum of the angles of a quadrilateral, so that's like a square, a rectangle, a parallelogram, any quadrilateral, the sum of that is 360. Now the reason for that is if you have any quadrilateral, we'll just take this one, if you were to draw one diagonal, it creates two triangles, and so if this is 180 and this is 180, then the whole thing would be 360. By the same token, and this is just for your information, if we were to take a pentagon, if you were to draw diagonals from one vertex like that, that would make a triangle that's 180, another one that's 180, and another one that's 180. And so that would be 180 times 3. And so that's going to be 540 degrees. And so any pentagon has angles that add up to be 540 degrees. And the pattern goes on. So there is a pattern to that. There is a formula so that you can know, like if you had a 10-sided polygon, how many degrees would that angle add up to be? And so that's not something we're doing this year, but that's just a little FYI. Okay, the second thing to remember is vertical angles. So vertical angles by definition are non-adjacent. So the word adjacent means next to. So there are two angles that are not next to each other, and they're formed by two intersecting lines. Vertical angles are congruent. So as an example of vertical angles, if I have two intersecting lines, they create four angles. So if I call this angle 1, 2, 3, and 4. So the vertical angles, well, if I look at angles 1 and 2, they're called adjacent angles, and that's because they're next to each other. So 2 and 3 are also adjacent angles. Now, there's something true about adjacent angles. Because this is a straight line, if you take these two angles, they would add up to be 180 degrees because it's a straight line. But with the vertical angles, the two angles that are non-adjacent, so for example, angle 2 and angle 4, those are called vertical angles, and they are congruent to each other. So I would say that angle 2 is congruent to angle 4. So if I knew that angle 2 was, say, 76 degrees, then that also means that angle 4 is 76 degrees. Can you see some other vertical angles in this picture? Okay, if you said angle 1 and angle 3, that's correct. Angle 1 is congruent to angle 3. So if I knew, for example, that angle 2 was 76 degrees, then angle 1 would have to be the supplement of it, or whatever else it would take to get to 180. So that would be 104 degrees. And so then angle 3 would also have to be 104 degrees. And so I learn a lot of things by these angles, by these things that I have to know already. So I know that these two are supplementary. That means they add up to 180. I know vertical angles are congruent. And that vertical angles being congruent, that's a super important characteristic. Okay, the next thing that you need to know from prior knowledge is what an isosceles triangle is. So an isosceles triangle is a triangle that has two congruent sides. So if you have a triangle where you have this side is congruent to this side, that's called isosceles. It might be that maybe these two sides are congruent. That means it's isosceles. In case you're wondering, if you have an equilateral triangle, that is also an isosceles. It's kind of like how a square is also a rectangle. An equilateral triangle is also an isosceles triangle. Now, in an isosceles triangle, one of the characteristics that's very important is that the base angles, which are the angles opposite the congruent sides, are congruent. What that means is in your isosceles triangle, these two angles that are opposite your congruent sides, those are called your base angles, and they're congruent to each other. So that's important because if you have an isosceles triangle, and so if you know that those two are congruent, and I know that this is 70 degrees, then I would also know that this is 70 degrees. Another thing that I could do with that is if I knew that this was 30 degrees, since I know all of the angles add up to be 180, I know that 30 plus, if I call that x, then I have to call that x because they're the same, would equal 180. And so I can set up an equation so that I can find out what each of those other angles is. So I'd subtract the 30 from one side, I'd have 2x equals 150, I'd divide both sides by 2, and so I'd get x is equal to 75 degrees. So both of those would be 75 degrees. So the fact that the base angles are congruent in an isosceles triangle is a very important characteristic. Okay, now the next thing, this isn't necessarily prior knowledge, but this is something that we're going to be using a lot of, and this is a conditional statement. So if you think about a condition, so if I say, I'm going to let you do this on the condition that you do something else. A conditional statement is usually given in if-then form. So if you clean your room, then you can go to a movie. If you work hard, then you can get good grades. And so the condition is set, and then the consequence is also set up. The if part is what we call the hypothesis. So if you do something, so that's the condition part of it. The then part is the conclusion. So what will happen if the condition is met? So in this example, if you clean your room, then you can go to a movie. Going to the movie that's going to depend on whether you clean your room. So cleaning your room is the condition. Cleaning your room has to happen first. So when we talk about a conditional statement, you have to recognize which part has to happen first, and then the conclusion will happen. Now, when we're proving things, we've already talked before about proving and the burden that's there, but when we're proving that triangles are congruent, there are different ways that you can do this, and that's what we're going to talk about in this unit. You can prove two triangles are congruent if you show that all 6 pairs of corresponding parts are congruent. So if you show that all 3 sides are congruent and all 3 angles are congruent, then that's going to be 2 congruent triangles. It is possible, however, to show that 2 triangles are congruent using fewer than those 6, and that's using specific postulates and theorems. And so in this unit, we're going to learn about those postulates and theorems. So what are postulates and theorems? So we've talked about theorems before, specifically Pythagorean theorem is one that you're familiar with. A postulate is kind of like a building block. It's like the foundation of everything. And so when you have postulates, they are statements that they're assumed to be true without proof, and that's because nobody's ever been able to prove differently. Everything else is based on these postulates, and so if something were to happen that somebody all of a sudden could prove a postulate was wrong, then everything would fall apart. And so these postulates that we have, they are just true. They're just an accepted truth. Theorems are built on the backs of postulates. And so like the Pythagorean theorem, we talked about how you can prove the Pythagorean theorem. You can prove theorems. Every single theorem can be proven. Postulates can't be proven because they're just the basic fact. And so we will set out to prove some things. And just so you know for future reference that if there is a theorem, it can be proven. It might be hard to do, but it can be proven. So for this assignment, you're just going to use that information that I've gone over to answer the questions in the homework. And mostly you should be able to get through the whole thing just based on the things that you already have learned and things that you've seen before and the things that I just told you. I'm going to go through and just do a couple of homework problems to just kind of explain, just in case something is not clear. So I'm going to do number 4. And so it says, if I look at my 2 triangles, notice how the markings are there. So if we notice like this is a single mark and this is a single mark, that means that this side AC goes with RI. The marks with the 2, that means that AB goes with TI. So if this says AB, then do I put TI or do I put IT? Based on the other questions in that 6, you should be able to figure out which one, but it does matter the order that you're saying that in. And so you're going to need to decide. So one thing that I do to look at that is I look at the other symbols. So if I'm going to say AB, I think about this. I'm going from the angle with 1 mark to the angle with 2 marks. So when I look at this side, I'm going to say the angle with 1 mark to the angle with 2 marks. It's going to have to be IT. Okay, one other thing about notation here is you'll notice that we have this symbol over the top of AB, and that means it's a segment. And so that is the notation for a segment. So if you say 2 segments are congruent, then you have to have the segment symbol on top of it. The next one I'm going to do is I'm going to just set up number 12. I'm not going to complete it, but I'll just show you how I mean to set this up. So the first important part of this is this congruent statement. So this congruent statement tells us that angle L is congruent to angle P. It tells us that angle M is congruent to angle Q, and that's because of the congruent statement. Those congruent statements matter. It also tells us that LM is congruent to PQ, so this is congruent to PQ. It tells us that MN is congruent to QR. And so because of all of that, I can set up equations to find the missing things that I don't know. What I'm going to do in number 12, it says find X. So if I look at where is X, X is in this angle, and so I have to find what that is. So what do I know about angle N? So look at my congruent statement. What do I know? I know that N is congruent with R. Here's R. So you're just going to set up an equation that says 11x plus 13 is equal to 57, and you can solve it and find R. So with all of the problems like this, that's what you're going to do. You're going to set something up so that you can solve that equation. In this next section, it's a couple of quadrilaterals. And so same thing, you're going to look at the congruent statement and what goes with what matches. And then you're going to be able to set up equations to solve for all of these things. Remember that the four angles in a quadrilateral, what do they add up to be? Okay, you'll need that information. You're going to need to set up like this side is congruent to this side, or this angle is congruent to this angle, and so you'll be able to solve it. Remember what this symbol means right there? Okay, with that information, you should be able to complete the assignment. And then next time we'll go into lesson 11.2 and learn more about proofs.